Hey, good morning. My name is Yu Norton Lee, and thank you today for joining my session, the MIC Resident Housing Property Sale 2019 to 2023 Analysis and Insight. So, let me introduce a little bit myself. I'm a data engineer, and for this project, I really thank you for my friend Wulin Fu. She actually tell me a lot a good thing of this the data set for this MIC Finance Department of Finance data on the housing sales. But unfortunately, she has some of the personal issues. She can't join today's talk. So today's talk will more focus on the data pipeline side instead of the analytic. I will also try to give some of the analysis during my data pipeline as well. But those is more focused on the how I get the data and then play around the data and then get into the model. So let's start on this. So the first slide you see on the screen is that I draw this slide on the Lucid chart. And this slide can show you like the full overview for today, the project. Actually, we're including some of the data, all the data end to end will be start from, for example, this data will be going to the extract from the MIC Department of Finance website. You will see all this raw data will be flow in the first step is in the data wrangling. It's more as well as you know is the data cleaning step. For this data cleaning step, after that you will going to store intermediate data into a refined data set. For this data set, we will start into the two directions. One is the data analysis, the report, the visualization. It's more like the analysis part here. And the second part will be we will obtain this data and then do some of the feature engineer, followed by the machine learning model training, and then we will also apply this model to do the future application. Right, you're using some unknown data, and then you can predict using this model as well. Okay, let's go to the main part of the notebook. Yeah, here I just like to create a notebook for this called the end-to-end run report. If this notebook, please also make sure you had to using the better to be using the Google Colab because it's free and also it has all the prerequisite like all the library already installed for you. You don't need to let the install library by your own. Yeah, because I also have some of the experience before. If I using the own the Anaconda, the Python setup, it will take a long time to just install the library. Yeah, Google here is give you everything already. So let's start from the notebook. The first you need to try to keep the Google about the access from the Google. Just to load keep those data access because you need to save the data. So the first thing first. So where will you get the data? The data actually is from the because from the New York Department of the Finance. I grabbed this data from the website called the Financial and Annualized Sale Updating. All the data from here is just this Excel file. Like first in the beginning, like how do you have to collect the data? Because the data can be from either the API or either from the other website. Or either from the SQL database as well. So in order to grab the data, the first thing, you need to kind of to understand all of the data, how is the data looks like, and then where you can extract those data is for here. See, actually here the page I saw all the data, all of this data that originally will be in the Excel file. So all this Excel file you will see download is like piece by piece, and then also by the file borrow, and then also by year. So after I start to download all this data, the first thing I need to do will be I need to combine all this data by using this following Python codes. Let me uncomment. Yeah, this is the first thing. All of this, the Excel data will be combined into one big piece Excel data. Because if you have, let's say, more than 10 pieces or 20 pieces of the data, it's very hard to analyze it. The first thing is that you need to try that is combine all this. After I combine it, I will have the combined piece I call the MIC property sale 2019 to 2023. For after the data ready, so all of this data it will be run into the data wrangling step as well as we call the data cleaning. For the data cleaning step, first, all this data, I would like to try to understand what about the structure of the data, what kind of the data it looks like. You get an overview of those the data heads of these the combined data sets. For this data set, I would also like to try to understand the shape of the data. For example, you see this, there will be a 221,000 the record on this data set with 21 column. And all these column are just doing some simple like the checking of the value of some of the column. As well, I will do this some of the to check how many the column name of this for all this to understand as the data also as well as the data type, because the data type as the engineering will really care about the data type, because all the data type here it will be because you need to categorize this data type. Like data usually have two types, categorical and then the numerical. This data type is important for the future like the machine learning model to build up. So after I like to browse after this data type, the next thing will be, because on this data set, because like all the data I grab it from this, you have like the different class of the the housing cell. This cell actually have the class, let's say the class 1 and class 2. And only for this project, we only based on the class 1 because it's more focused on the residential property of the housing. Like the way we only choose residential, because if you combine also the commercial data, the model it will be hard to kind of to build up, because you know that the price difference, the commercial and then the residential data will be a huge gap here. So in this situation, I will only select which the data only using the class 1, which is 1.0 for long that this data set on top. So after I select only the class 1, you see the data size already almost dropped to 50% reduced. Right now you only have about like the 200K of them the records. And the next thing also like very important, like you need to check also the missing value, because like too much missing value for that column is no good. Usually we don't want it. The way we like to check this as value, and later on we need to get rid of the missing value, or either we can like to do something like the impute to the replace with the either the mean or media. After I check those missing value, the next step I will do like checking all of the numerical column as well. Then this numerical column also will be a part of the mod for most of the model. For example, like the linear regression model, you need to understand all of those the relationship later. I will also check this. You can see that some of the column you see a lot of the null value and the n value is a missing value. You probably will need to also deal with this value later. And the next step, some of the column you can see is a string at the beginning, but actually we don't want a string. We want it as in the integer in the beginning, but we want it as a string. So for example, like the Bolo here, because the Bolo here will be indicating 5 of the Bolo, like all of those Bronx, Brooklyn, Manhattan, Staten Island, and Queens. Yeah, but those value is no meaning. Like if they assign 1, 2, 3, 4, 5, so it's better we kind of change to the string. When you fill into the model, those values will not involving into the computation. Another example, for example, is like the block and the log. Here, I also need to convert this into the integer as well. Yeah, and some of the year bill and the loss, they have not only have the integer full or integer, but they also need to be kind of you have the null value, missing value. In this case, we also need to keep it the null value for kind of for ready for the model. So here I just do a little bit more like to complicate it, do a lambda application to keep those null value remain in the column instead of remove them. And the next one will be the self year data, that self day data. I only extract the year because it's much more simpler. Because for the self day, you have like the year, month, and date, which like when you plug in using the by year in the data visualization, it will be a little bit difficult to give you like the despite the whole year data. Yeah. So after about the wrangling, the cleaning, so I will have the data set a little bit more clean, and so but let's the next thing will be go to the doing some of the data conversion. The first thing will be the borrow, because in this day the borrow is already assigned in the beginning will be a number. So in order to do that, I need to assign that back to a naming. It's better for the data visualization purpose and also for analysis purpose. Here you do a mapping. After the mapping, you will see that all of these 1, 2, 3, 4, 5 will be assigned back to the all the corresponding borrow. And here we just showing like some of the interesting like the funding. Probably, for example, like the neighborhood, you will see that the first top 10 value count for the neighborhood in order to sell them. Most likely you see this in the Queens. This is also like really interesting because I think Manhattan usually will be the highest one, but here it's more showing the Queens. It's also making sense because Queens has much more like the newer building apartment compared to any other like the boroughs. Yeah, here also doing some like the building class category. You see the one family dwelling has the most like the counting for the sale during last 5 year between the 2019 to 2023. Yeah, and also when you check the year of the bill, you will see that New York City has the most like building built from the 1920, which is kind of old, but they still like a lot of selling from there. And also like the top 5 of the list, it can also that MIC building is very old as well. It's most of them already past like 100 years since they are built. And the next one, like the most important parameter, the sale price we are looking for. In this value account, we can see that actually most like the people of this selling is at the sale price of 0 or either the 10. So after I kind of to check those the website, the definition, this 0 is sale price 0 or 10. It just meaning probably this house is just sell from maybe between the family, from the husband to Hawaii, from the wife to children. Or that's why you see that the sale price has nothing there, or either maybe $10 just for transfer title. That's mean if we haven't built the model, probably this 10 and the 0 and 10 we would like to ignore it to drop it from our data set as well. Yep, after we drop this at the sale price from this not equal 10 and 0, and then our data set reduce another half again. So right now we only have 1,200. 122,000 compared to the beginning we have 400. And then the next one will be like to doing another like the conversion for the another column like the zip code, because the most like the zip code like we will better consider as a string as well, because the zip code as a number has no meaning like in the model. So the next one will be just like to show you if we like to run it by the to check this data type. After I convert it, you will see some of the data type will be changed. For example, the zip code will be converted to the from the integer to object, and also the borrow here you have the borrow name. I also like to convert to the object as well. So after we have like some of the clean data, so next thing we'll be doing some data visualization. In this data visualization, the tool of the library usually I will use. The first one is the Seaborn. Yeah, I know somebody will maybe prefer to use the Matplotlib. Matplotlib is good, but the only thing, the Matplotlib, you need to implement all the parameters by your own. But the Seaborn already help you to wrap up some of the parameters. You don't need to worry about that. So in this Seaborn, some of the graph, for example, I plot out the sale price that is called the logs transform sale price distribution versus the count. Here, why we kind of using the log transform, because if we're using a real price, you will see the gaps very large. You will see something in the 0 and something to a 10 million. Then you will not see like the graph more like visible. So if we're using the log compare from this lot, you can see that the log size from the 10 to 18, you can see that also it's like the exponential increase from the 22,000 to 6. I think this is like 65 million. But this is in with the lot, you can see more like clean, and then you can see that most of the house sale price is between, I think, between 13 to 14, which means about 414 to 1.2 million distribution in here. Yep, there's also the sale. That's the box part also very so similar the distribution here with a different representation when you're doing the histogram and the block plots. And also, if later I will try also to do the by Bolo. When you see the Bolo by the log scale, you can see that Manhattan always on the top, because as you know, Manhattan, a house in Manhattan, it has the highest price for among all of the other. And for this also something like interesting, I think the Queens is like a little bit interesting thing, because let's see here. Oh, not the Queen. I think about the year. Yeah. No, maybe not this graph. Let me go to the next one. Also you see the distribution by year. Actually, this 5 year you don't see a high the distribution variation from this all of this based on the yearly. The same data. I do another plot using a violin plot. Actually, the violin plot, you can see that the distribution shape, right? More price is more like the diverse in the Manhattan compared to the other 4 boroughs. And the next one will be the all of this the distribution by all of the 5 borough, and then you can see it by most expensive neighborhood in each borough to show it the plugin. Yeah, one thing I like is also interesting here, because let's say in the Queens, actually the price is showing relatively lower compared to that Brooklyn. It's more like also up making sense. Queens has one of the highest sale price, but actually will be more the apartment in Queens. That it will be also making sense that price in Queens it will be relatively lower. Apartment compared to the one single family, it will be has some sort of lower price as well. Yeah, and here you see that based on the year, you can see this like the total of the medium sale price from compared to all of the this 5 borough, and Manhattan actually is showing the highest one for sure. But the one interesting thing here is that Manhattan actually in 2020 showing the highest median price compared to the 2021. But for the other 4 of the borough, you can see that the peak of the sale is on the 2022. After 2022, the price dropping is also making sense. Since if I remember correctly, the federal increased since 2022, they increased the interest. Like people will have the less and the money if they will come with the higher loan. They do not buy. And here I showing the graph over to showing the total and the median sale price over the time. And you can see that's like as the median of the price also will increase. The total amount of the sale when it reached out to 2021, that is the year with the lowest interest. But also most of the people like buy the house on 2021. After that, the housing of the total sale amount is decreased. But however, the sale price is still increased at that time. Yep, for this first part with also data visualization, finish the Seaborn. I also do some of that with another data visualization tool. It's called the Partly. In this Partly, it's just like the thing good for the Partly is it will be show a 3D dimension plot like this. You can do even more 3D. Here is showing 4D. You can see on the X and Y it will be at the growth, the year sale, the gross square feet, and also the sale price, and then you can add a 4 dimension as the borough as well. And when you remove all this, you can see each individual is the data is more interactive. You can see what the actual value for each data point. Yeah, to another of these with the partly data visualization. You can see by different the class category. You can see a change for all of this class during like the 5 year 2019 to 2023. Yet continue to do another ones by different borough. Yeah, you can see in Manhattan will have a different. There's a huge difference based on different class. Yeah, there's another ones by the category, the building category, and then the borough over is average sale price over time by borough and building class category. Yeah, here above will be the data visualization, and the next thing, right? Because uh, all of the data is there, but in order to like to get the better to get into the machine learning part, we will need to do some of the called the feature engineering. Feature engineering is actually it will be improve the model performance by like the creating those relevant, informative, and the not redundant feature from the raw data. Right? For example, in this feature engineering, first thing you have that to check all of those numerical data, and then we check the correlation on all of those numerical data to understand which of the numerical data might be like close to the our target of the target column for this is the price, the sale price here. Yes, for this sale price. So let me see what I'm doing. Okay. Because for this sale price, let's for in the about because we saw some of the price are very low. So for here, I just using a 20,000 cut off. If like the price lower than 20,000, I'm not going to put it into the model for using because like 20,000 single family how it looks like is not that making sense even for apartment. So after I drop this those the remaining of those house less than 20,000, I will get around the 1,200,000 final data set, final data in this data set. And the next thing, for most other for feature engineering, and we either create some of the feature which is related to those sale price, but not like to using the sale price column, the sale price column. For example, some of the new feature I've created is one is called the building age. For this building age, I can use the sales year to minus the year of the build in order to get the sum of the age between from the sales year and then between when they sell it. Like another feature like the self month, self season, building age, bin, like text class change, unit density. This feature will be kind of like to increase, to implement, and also will attach to the current refined data, and then as a new feature as well. But also for some of the original column, like for the column, some of the data, some of the column because they have either have too many NaN value or either they are kind of redundant. So I will kind of like to drop it, or or maybe they don't have any of the meaning. For example, like the borrow name, sell date, easement, apartment number, and the address. For those of this unrelated or this unmeaningful column, I just drop it because in order to get the better feature engineer. So after I drop it and then to add the feature, the feature out here, the shape will come up around 24 column compared to 21 before. And then because we add some and then we drop some of it. So once the feature engineering done, we will ready for the machine learning modeling. In this machine learning model demo, I will choose like two of the model. One just like the simple model. One is the linear regression. The other will be a random forest. Like most of the people when they touch the machine learning, probably they will heard like those like the linear regression, logistic regression, decision tree, random forest. That this form will be the most common people will use when they do the intro into the machine learning model building. So in this machine learning model first, right, in the linear regression, the target column we will set it as it will be a sale price, and and then all of the training for this training model, all the other data set, I mean all of the other column will be used as a training column. So here we set it split into a X and Y. X will be 23 column here. The Y is only will be a target column is the sale price. So here we were doing some of the data handle before we highlight to change this fit this data column into the model. For example, you will highlight to replace some infinity value with the null value. And here I'm using one of the very useful like the library is called the pipeline. In this pipeline, I can highlight in the pipeline, inside the pipeline, I can show all of those hyperparameter tuning of the machine learning parameter. You can using that, for example, the imputer to find for the filling the missing value, and then also for the standard scaler to normalize the data. But for each step, you can see that once you have this including, you will see all of these like the piper parameter inside of your model. And the next one will be kind of to do it some of the called the transformation for, because as I mentioned it, that your data you will have like the numerical data and also the categorical data. You need to paste these two data into this kind of transformer here, and then also you need to do some of these transforming. Here inside actually we will have some of the mathematics here, but here like as a high level, you just need to wrap up the processor and then put it using one's called the one-hot pot encoder here. One-hot pot encoder kind of simple to say. You just like to convert all of your categorical data. For example, if your category had 3 value, in this the one-hot pot, it will be use a binary method to combine to divide this 3 value into 0, 1, 0, 1 for each 3 value column here. And the next thing will be do a train test with all your model. Here I'm using like the 13, 17, and then with a random state with 24, and then all this model training data will split into like the 4 sub data set: X train, X test, Y train, Y test. For this X train and Y train, we will be using for training purpose, and for X test and Y test, we will use for the testing to validate the data. And this data we put into the model under here. So in the this model, we will also like to calculate this MAE, MSE, MSSE, and then the R square. Like here, I'm not going to do a lot of map here, but only thing I'm looking for this model will be the R square. When you see this, like the model, when the model set up, you will have like the processor, transformer, and in the transformer, you have like your numerical category and the categorical category here. All data will be in the, for example, the numerical, you will see it is in the simple, we undergo the simple imputer, the standard scalar. For the categorical, you will see that is you undergo the one-hot pot encoder. And after that, you will apply all of this refined data into the linear regression. And then after your final answer, the final R square actually will compare your linear regression data for the training data set, also for the Y testing data set. Actually, the result only get in 0.34a, which is low, right? Because we know the R square is better. The better R square should be more close to 1. That means linear regression for this model probably is not a good selection for here. So the next model I would like to run into the random forest. In the random forest, like we're doing the similar like the setup. We're using the CellPy as our target category. The other will be a the train data column. And then also using the same of the 30% of the test train test split, random state 24. And all of these, like the step, will like the similar remaining, and you see that pipeline, and we go to the end to server here. Once I set up the model, you will also see that in here you have the processing transformer, the numerical and the categorical data will be including. Here you will see a slightly different for this model to compare to the linear regression model. We don't need the computation, the imputer computation, and all the standard scalar, because random forest is allowed in using the missing value. But linear regression, we are not allowed to use that. So after we like to transform this into a random forest regressor, our R square gets improving. Like here, now we have almost 67%. It's also indicating for this housing cell model, all of the model, the data is better to using the random forest compared to the linear regression. So after we get the model, right, the next thing, how we can apply this model into the real machine learning pipeline. So once we get the model, we can save this model into like usually we save the model as a pickle file. Pickle file is just like, actually, I'm not sure why they're doing pickle file, but only thing all of the things we save in the pickle file is just the model parameter. So there's no real data we save in the pickle for here. So if I save this pickle, I try to verify what I'm seeing here. I try to read the pickle, and then you see all inside this pickle. When you read it, all of this hyperparameter is just what we set up on above. So after we get this pickle file, the next thing we will be apply this pickle file and then get some general to feed the data, unknown data into it. Here, I just as a demo purpose, I will like to just get the file of the data load from this test data. I try to remove of this target file here. I try to remove this original target price, and then I replace. I will set it as job it, and then I'll be using this machine learning pickle file to load this, do a prediction, and then this prediction for the new data set I'm calling the predict sale price. And then aside back to this machine learning model, you will see that there's a new column at the end. It's showing like called the predicted sale price. Actually, when you compare this sale price, it will be applied with the random forest model, but compared to whatever originally we have in our original data set, you see it's kind of different here. Yep. If, for example, here, if you get a better model, usually you will have like the more closing the prediction compared to like the original data. Because here I just doing like the demo purpose. I didn't like to spend a lot of time to tuning those parameters. But if you can get this R square up to 90% for your model, even better, you will get a much closer to predict the price from compare your original model price and then to the predict model price. Yep. Yeah, let me go back. Yeah, here's almost how I like to using this end-to-end machine learning model for the demonstration. So like, for example, like if like for most of the people, when you run into machine learning, you will have to see like the following improvement when you like to improve your data. I mean the model accuracy, for example, the data quality, the clean data, the feature engineering part, the outline handling, some of these like the feature like selection, remove the redundant data, feature also like doing some of the feature important to check the data, and then also recursive feature elimination, like also feature scaling. Make sure also you like to normalize the data or standardize your feature before you feed into the model. And then also the most thing like the thing people are easy to change, like select the better model. Usually when we do the machine learning model selection, we usually will take 3 to 4 models to run that under it, and then also do a tuning as well. Thank you. I think that's all of my talk today. Probably I'm running a little bit fast and rushed. Yeah, if you have any questions, just like to let me know. Yeah, I opened all the questions. Thank you so much.
I did want to call out, Norton, earlier in the chat, there was a question about getting a link to your notebook. So I think people were wondering if it would be possible for you to share your notebook.
Yeah, I will share the notebook after I finish this talk. I will post to the GitHub. Yeah.
And David's asking, well, let me start from the beginning. It says, really good presentation. I'm fascinated by the data wrangling step. It looks like you did a lot of data manipulation in this step. Did you find data that was in error? That is, some data anomalies that were incorrect or invalid?
Yes, I did. I did find out some of the data. That's why in the beginning I tried to remove some of the column. That column already, for example, like if I choose commercial data, there will be some of the values not making sense for me at all. So that's why I didn't choose that. Once I drop the commercial column, I already removed those like the data. For the more like the residential data, the error has been reduced. But for some of the columns like in commercial class, they have a lot of error, or some of that I don't understand what they mean. because I didn't show it here. But when I do the data wrangling, I found out those data. I drop it. Like for example, some of the year they probably even the human typo. They make it some year like 2002, I think the 2020 something year is like not mixing at all. In that case, you need to do a data wrangler to get rid of the data before you move like to refine all of this data column.
So the question in the chat, it's from Gabriella, and Gabriella says, are your data analysis and models integrated with the New York City Housing Authority?
I would like to do it that way, but because the time limit, I don't have the time to find out those like the key to join. In order to like, if you want to get the bigger data, for example, you want to combine the data from outside of this data set, you need to find out the following key to join. Once you find the following key to join it, you will get more like the information, which like we can combine the two data source. You will have them better like, to get the feature later. Yeah, that's what I also think about it. I also using the department of the building source because that department of building even have a large data set compared to the department of finance. I don't have enough time to kind of figure out this part, but that will be if I had the time later, I will do it by my own later. I also will push into the GitHub to show if I can find out some of the column to join.
Hi, Gabriella. Just wanted to expand on my question. Thank you for showing us these exceptional visualizations and data wrangling. So yeah, I guess I asked this question because I work with a data scientist daily at my startup called Lunamaps. And what we've been finding in the public sector in Boston is that they also have a very wide open data dashboard with similar like over 1,000 data sets available to the public. And there is further reimagination of data modeling and data visualization. So I think just based on your work, there could be some really interesting design challenges for the city of New York to kind of unfold in presenting such critical data on housing, property sales, both commercial and residential. So yeah, I don't know if the organizers can speak to like whether the city of New York does have these kind of like open design calls for folks like you and other people on this call to maybe submit a bid or be involved in creating range and visualizations.
Yeah, my understanding like because the data like each like the department have like each the different style. What I will find out like if they, for example, if everything related to housing, if they have create some like called the unique ID, we can use that one as like the connect to join as a join key. Otherwise, you have like 10 maybe it's 1,000 data set. If you don't find a join key, it's hard to interpret it with all of the connecting. Once you have those like to create a join key for like let's say like each like for example the department of building, department of finance, department of the housing, if they put like for each housing, if they have like some common key there, it will be easy to like to connect later because it's not like the what I say because some of this I know it's very hard to like to communicate with each department. But once like when the data the design, if they have more like the comments like the column there, it will be easier for like data scientists, data analytics to kind of to grab the data together. That's what I find out when I'm doing that data exploration.
Very helpful. Thank you.
So I think next up in our chat, there's a question from Leanna. Leanna says, thank you. And could you please explain a little bit about when you filled the missing value using the mean? How did you prevent the data leakage? Because it looks like you filled NA before doing the train test split.
Actually here, I didn't do like a lot of dealing with those N value. Yeah, technically, I should not do the imputer with the mean. Even I can leave it empty, or even I don't choose the linear regression model. But that's why I choose the random forest as my preferred model here. Because random forest, it doesn't matter you have the missing value of not. Technically, we are not allowed to delete any missing value, or we are not to replace those value as a median or mean, unless you have some purpose. Yeah, that's what in my like the daily job. I'm not doing like that way. But because it's for demo purpose, I will just showing because I want the model run. It's good, but that's not a good way to do it. Not a good practice. Don't do it. Yeah, if just keep the missing value there. Don't or either you're using a machine learning model, you can handle the missing value. Just leave it there. Because if you create something, that means your model will get interrupted by human. It's not a nature of the model to predict.
Great. And then next up, we have a question from Vlada Moody, and they're asking, where can we get the property taxes and insurance data for New York City?
Good question. I think the property tax you can search that. I don't remember one of the New York the website they have like all the property record. You can search there. I forgot that the website. It's open. You can search by your lot number and then search the property tax. But I'm not sure if they have highlighted database to highlight to share all the property tax in one piece. Probably not. But based on if you know that this like the property sale, I think if you know how they calculate the property tax, then you can do a calculation by your own. You can create a new feature to do the property tax, and then you can compare the property tax compared to your property tax, and then compare to the one you calculated. Then will be another thing you can do it. Some of the information probably they don't give it to you, but you can indirectly get it.
Next up in the chat, I believe we may have answered this already, but there's a question from Sherry, and Sherry's asking, could you please explain again how you processed those with null or missing values? Were they part of the DF or I guess data frame, analyzed or removed?
It depends on the percentage of the of those now. For example, in this data set, if we go back to the beginning right here, for like the Eastman apartment number, there's a huge like the missing value. That's why if I saw like this way, I only have 400K. I have 400K missing value. I just don't use it. If the missing value more than 10%, I either don't use it or I need to drop those missing value. It depends on how important of those values. So usually what I'm doing, I try to do pick a model using the missing value, handle the missing value, and then without handle the missing value to compare first. If those missing value is not that important, I will just drop it. If important, I will keep it. That's how I like to deal with those missing value. But I will not replace anything. Either drop it and keep it.
Gabriella, this is David Tussey. I'll come on mic. Yuru, have you considered publishing this work? I mean, this is really academic quality for something like the Journal of Data Science. It might be a real good contribution.
Yeah, for publishing, I need to write a paper. I don't know what kind of values I read.
Yeah, you do. The editor of that journal, Dr. Jun Yan, is also presenting along with myself on Monday afternoon. And he has a dedicated presentation from his advanced statistics class at 2 on Monday. And it's an opportunity to sort of see the kind of work he's doing, which is right close to what you're doing. And he's deeply involved with the Journal of Data Science and might be interested in speaking with you about a paper. It's a terrific presentation and very well organized. Thank you.
Okay. So great. So if I have time on Monday, I will join the meeting.
Yeah. Of course. I'll send you the link.
Yeah. The reason I like to perform here that because this is like how like the people like to doing the modeling. Because like once you get the data, how you handle it, clean it, and then make it into the model. It's more like because machine learning is more popular like recent years. So like most people want to learn from this. That's I also I have the opportunity to demo this how I kind of to get the data in order to put this data into the model. Yeah, this simple. So in the simple way.
It's also a great demonstration of the Google Colab feature and the capabilities that they're providing, both in terms of code visualization as well as machine learning models. Pretty impressive.
Because when I took class before, like the first couple of years, I was just using the local environment, which is technical. But once we know the Google can handle like most of the library, just use it. Because even here, I don't need to do a pip install. You just like to import something to something, add something. That's it. You can use.
Is that tool able to handle much larger data sets?
Yeah.
Or have you?
You need to pay the GPU.
Oh, you have to go out of the free to the paid version
Yeah.
if you want to wrangle 20 million rows or something like that.
Yeah, true. Or either you can do a Google Gemini on the AI API into it right now.
Yeah, sure. Okay,
Yeah, but
thanks.
in that case, you need to kind of to improve a little bit your GPU, the CPU to when you run this model. Got another question say how do you run the maintain for this model? Often update the parameter. Yes, like for example, right? You usually when you do verify the model, you need to verify for a certain amount of the period. For example, when you publish a model to predict, you need to using at least 1 year of the data to check. And then you also can check based on season, based on the monthly. You have the different the period to compare. You need to do some of the A/B tests on it to see if you using or don't using something like happening. And then compare. Then you need to see the variation of it, like that. Do an R square again to compare all of those the differentiation. And once you get those data very consistent, then you will publish. But probably maybe after another year, you need to do this evaluation again. Once you see that variation getting like 5% or bigger, you more probably you need to tune your parameter one more time for the next because since the pay of the people buying house will be have so many factors. Can be out external factor, can be internal factor. That's why all of those features sometimes might be out of date. You need to kind of replace the feature. And some of the feature maybe for example, some of the feature might be also have some of the restriction in the publication you cannot use at all. That's why you need to, in order to publish a fully the model, you need to get either the much more concern other than just you play around to academic the demonstration.
Okay, great. Thank you so much. So I think everyone, we are at time now. So feel free, as Narn said, to send an email if you have any more questions. And thank you. Thank you so much for joining us today. And a special thank you to Narn for this lovely presentation and really amazing visualizations. Really excited to see what comes from this. I personally hope you do write a paper on this one day. That was such a great idea. But just want to say, everyone, thank you so much for coming today.
Thank you all for joining.